Hey there, science fans! Today we're diving into the fascinating world of thin layer chromatography, or TLC for short. Now, TLC might sound like something you'd find in a high-tech lab, but trust me, it's much simpler than it sounds. Imagine you have a mixed bag of colorful candies and you want to separate them by color. That's kind of what TLC does, but instead of candy, it separates chemical compounds. TLC is like a detective tool for scientists, helping them identify the different ingredients in a mixture. It's quick, easy to use, and doesn't require fancy equipment, making it a favorite in labs worldwide. Whether it's analyzing the purity of a drug or identifying unknown substances, TLC plays a crucial role in many scientific fields, especially in the biomedical arena.
So how does TLC actually work? It all boils down to two key components, the stationary phase and the mobile phase. Think of the stationary phase as a thin layer of absorbent material, like a rectangular cookie sheet usually made of silica gel or alumina. This is where we apply our mixture. The mobile phase is a solvent or a mixture of solvents that travels up the stationary phase, carrying the components of our mixture with it. Here's the catch: different compounds have different affinities for the stationary and mobile phases. Some compounds are like homebodies, preferring to stick to the stationary phase, while others are adventurous, traveling further with the mobile phase. This difference in travel distance, known as the retention factor or RF, helps us identify and separate the components of a mixture. It's like a race where each compound has its own speed, creating a unique separation pattern.
Ready to see TLC in action? Let's break down the process into simple steps. First, we prepare our TLC plate by carefully applying a thin layer of the stationary phase to a glass or plastic sheet. Next, we spot a small amount of our mixture near the bottom of the plate. Now, it's time to introduce the mobile phase. We place the bottom edge of the plate in a shallow pool of solvent and let the solvent travel up the plate by capillary action. As the solvent front moves up, it carries the components of our mixture along with it. Remember, different compounds travel at different speeds, creating a separation pattern. Once the solvent front reaches a certain height, we remove the plate and let it dry. The separated components appear as spots on the plate. Finally, we visualize the spots using UV light or a chemical staining agent. By measuring the distance traveled by each spot, we can calculate their RF values and identify the components of the mixture.
Section 4. TLC and its biomedical significance. TLC isn't just a cool lab technique, it plays a vital role in the biomedical field, impacting our health and well-being in countless ways. One of the key applications of TLC is in drug analysis. TLC helps ensure the purity and quality of pharmaceutical products, protecting us from harmful impurities. TLC also plays a crucial role in disease diagnosis. By analyzing biological samples like blood or urine, TLC can detect abnormal levels of certain compounds, aiding in the early detection and diagnosis of diseases. From monitoring drug therapies to identifying biomarkers for various medical conditions, TLC is an indispensable tool in biomedical research, helping us understand and combat diseases more effectively. Section 5. Real-world applications of TLC. The applications of TLC extend far beyond the lab, touching various aspects of our daily lives. In the food industry, TLC is used to ensure food safety by detecting contaminants, pesticides, and additives in our food supply. TLC also helps protect our environment by monitoring air and water quality, identifying pollutants and their sources. Forensic science relies on TLC for analyzing evidence from crime scenes, such as identifying drugs, explosives, or ink samples. These are just a few examples of how TLC quietly works behind the scenes, safeguarding our health, environment, and safety.
Section 6. Wrapping up the power of TLC. TLC might seem like a simple technique, but its impact on science and our lives is profound. Its ability to separate, identify, and analyze complex mixtures makes it an invaluable tool in countless fields, from medicine and pharmaceuticals to environmental science and forensics. As scientists continue to develop new and innovative applications for TLC, its importance in addressing global challenges such as disease diagnosis and environmental monitoring will only continue to grow. So, the next time you encounter TLC, remember its power and versatility. This seemingly simple technique is making a world of difference in advancing scientific knowledge and improving our lives. Stay curious, my friends. Smile.